All right, heading right on into 1.2. Your objectives for this video is to graph and order real numbers and to identify properties of real numbers. Okay, so I'm going to show you a graphic organizer that helps me to remember the different sets of numbers. If you'll think of this whole box, whoops, don't want to do that. Think of this whole box around the outside as real numbers. And then within the real numbers, you have the rational and the irrational numbers. Irrational numbers are essentially numbers that can't be written as a fraction. Okay, so any square root of any number that's not a perfect square, square root of 2, square root of 3, square root of 7, square root of 47, none of those are perfect squares, so those are all irrational. Also, numbers that are decimals that don't repeat. Decimals that don't repeat and don't end. So, pi is also an irrational number. Okay, on the left, I've got all these little circles in here. That's because within the rational numbers, there's a bunch of different sets. Rational numbers are any number that can be written as a fraction. Okay, so that's going to be like 2 over 7, or the square root of 49, which is what? 7. Or 0.9999 with the 9s repeating, because a repeating decimal can be written as a fraction. Then, within the rational numbers, the biggest set is going to be the integers. So the integers are going to be the negative, 0, and positive whole numbers, not fractions. So negative 3, negative 2, negative 1, 0, 1, 2, 3. And it actually goes on and on in each direction because I collect all the negatives. Then within the integers, if I take the 0, if I take all the negatives off, I have the whole numbers, which is just going to be the integers without the negatives. So it's going to start with 0, go 1, go 2, 3, and so on. And then within the whole numbers, if I take the 0 off, I have the natural numbers. So those are numbers you count with. Those are your counting numbers. When you count, you don't say 0, 1, 2, 3, 4. You just say 1, 2, 3, 4. Okay, so 1, 2, 3, ... And that's my set of numbers. If you want this graphic organizer, you're going to get it tomorrow in class to put in your notebook. Alright, this is not supposed to say identifying a variable, it's supposed to say classifying a variable. But anyway, your school is sponsoring a charity race. Which set of numbers does not contain the number of people who will be competing in the race? So, you can't have a half a person. Irrational numbers are numbers that cannot be written as a fraction, so they are not whole numbers. You have to have a whole person. You can't cut a person in half, so it's not going to be irrational. And they're asking for which one is not. So right now it's just irrational, and it doesn't say that we only have to choose one. But if we're counting people, 0 people, 1, 2, 3, 4, 5, that's an integer. It's also a rational number. And the natural numbers, if we're counting, it's going to be the 1, 2, 3, all that stuff. So irrational numbers is the only one it cannot be. Alright, example 2, graphing numbers on a number line. This, for some reason, is really hard for people. But what you need to do is always try to put 0 in the middle. It depends on what number you've got, but right now I've got all kinds. So we're going to put 0 in the middle. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay? And you always want to space them evenly. You can't, on the right-hand side, go 2, 4, 6, 8, while on the left-hand side, you go negative 1, negative 2. They always have to be spaced evenly. So I have 3 numbers. I've got negative 5 halves, which is going to be obviously this direction, and it's negative 5 halves. So if I just wanted to count 5 halves, I would go negative 1 half, 2 halves, 3 halves, 4 halves, 5 halves, and it'd be in here somewhere. You just got to use your common sense a lot. So that's going to be negative 5 halves. Okay, got that one. The square root of 2. Well, the square root of 2 is approximately 1.4. So, and you just use a calculator for that. I just don't know that off the top of my head. But here's 1, here's 2. 1.4 is going to be a little less than halfway between 1 and 2. So I'm going to put a dot here. We're going to call that the square root of 2. And then 2.6 repeating is going to be 2. It's going to be between 2 and 3 and a little over halfway between 2 and 3 because 2.5 would be halfway, so 2.6 is going to be a little more than halfway. So I'm going to call that 2.6 repeating. And that's it. You graphed them. All right, the next one, what is the graph of all of these? We'll draw our number line. I've got positive, negative, positive. So we're going to start with 0, 1, 2, 3, negative 1, negative 2, negative 3. Then okay, negative 1.4 looks like the easiest. So I'm going to go left, negative 1, and then another almost between, halfway between, but not quite. So we're going to call that negative 1.4 repeating. Square root of 3 is going to be 1.7. So we're going to go from 0 over to 1. And then 0.7 is going to be probably 3/4 of the way. Close to 3/4 of the way. It's not exactly. We're going to call that the square root of 3. And then 1/3 is the last one. So it's obviously going to be 1/3 of the way between 0 and 1. So it's going to be about here. Okay? That's how you graph numbers. Make them all in the same format, and then they're easier to graph. Example 3, ordering real numbers. How do square root of 17 and 3.8 compare? So you need to put them in the same format. So we need to know what the decimal form of the square root of 17 is. And it's going to be about 4.1. Well, obviously, 4.1 is bigger than 3.8, so the square root of 17 is going to be greater than 3.8. Okay, got the square root of 26 and 6.25. So we're going to take the square root of 26 and get a decimal, and it's about 5.1. Well, 5.1 is less than 6.25, so the square root of 26 is less than 6.25. A lot of times students try to put on, you compare the decimals, but you have to compare in the form you were given. So I understand you need to find the decimal, but you don't compare the decimal down here. You compare what they gave you in the problem. All right, properties of real numbers. There's a bunch of different properties for real numbers. There's the closure property, which means if it's closed under addition, if you put in a real number in addition, you get out a real number in addition. So to show that, if you do a real number plus a real number, you get a real number. If you do a real number minus a real number, you get a real number. That's closure. All right, the commutative property means that I can move them around. Just like you commute to school every morning, you're moving yourself to school. So A plus B is the same thing as B plus A. This is supposed to say multiplication. I do that a lot, you'll notice. So this is supposed to say multiplication. So yeah, it's still closed under multiplication though. And you do A times B is a real number. All right, and then commutative, A times B is the same thing as B times A. Associative means that I can switch groups. So if I've got A plus B and plus C, that's the same thing as A plus B plus C. Just like if I have A times B times C, that's the same thing as A times B times C. The group can change. As long as you're only adding or only multiplying, the group can change. Then you have the identity property, and the identity is whatever you can add to a number that doesn't change the number for addition, and it's whatever you can multiply by the number that doesn't change the number. So what can you add to A and get A? 0. So 0 is the additive identity. What can you multiply by A and get A? 1. So 1 is the multiplicative identity. Then you have the inverse property. So what can you add to A to get 0? Negative A. What can you multiply by A to get 1? 1 over A. Identity and inverse tend to confuse people, so pay close attention. And then you have the distributive property, which kind of goes over addition and multiplication. If you have something multiplied by addition, like A times B plus C, that's the same thing as A times B plus A times C. And that's the distributive property. All right, example 4, identifying properties of real numbers. I have to write the problem in because I couldn't get the fraction to show up. So it's negative 2 over 3 times negative 3 over 2 equals 1. Well, I multiplied something by something and got 1, which means that is the inverse property of multiplication. So instead of writing it all out, I'm just going to do end prop mult. And you know what I mean. B, 3 times 4 in parentheses times 5 equals 3 times 4 times 5 in parentheses. Well, when the group changes, that means that that is the associative property, and I'm multiplying, so I'm going to say it's this associative property of multiplication. Alright, so you try. I go 3 times g plus h plus 2g, and that becomes 3g plus 3h plus 2g. So obviously I multiplied the 3 by both these things, so that's going to be the distributive property. Alright, this is your turn. So you're going to write this on your own sheet of paper. Make sure you have it where you can turn it in tomorrow. If there's any work to be shown, you have to show it or you will not get credit.